everyone. Today we're looking at, or this week we're looking at recursion. So recursion is the process in which a method calls itself until some specified condition has been satisfied. So what that comes down to is basically a method is going to call itself. So a method is calling itself inside of it until a condition has been satisfied, so we don't get into an infinite loop. All right. Before we look at recursion in Java, let's take a look, because some of you have done recursive methods in math and analysis. So let's take a look at a math example first, and then we'll come back and look at it, what it looks like in Java. All right, so let's look at a math example first. Whether you've seen this in analysis or this is the first time seeing a math recursive function, you should be able to follow along. So I have f of x equals f of x plus 1 plus x if x is less than 5. So if x is less than 5, I'm going to use this function. Okay, I'm going to use that function. Otherwise, so there's my else statement basically, I'm going to use x squared. All right, and that's my function setup. So let's kind of go through it. We're going to find f of 2. Let me move this up so I have enough room. I'm going to find the answer to f of 2. Okay? So I like to work kind of down. I'm going to kind of do this in some different colors, hopefully, so you can see this. So f of 2, let's think of what f of 2 is. Well, 2 is less than 5, so I'm going to use this function up here. So f of 2 is very simply f of 2 plus 1 plus 2. Okay? And I can simplify that down to just f of 3 plus 2. So f of 3 plus 2. Now, if I can't get that answer because I don't know what f of 3 is. It's not like f of 3 is just 3 and 3 plus 2 is 5. I need to find out what this is in order to, like, if I can get a number here, like 30, well then it's just 30 plus 2. Okay, and that would be the answer. So I got to figure out what f of 3 is. So this here I'm going to do in red now. Let's figure out what just f of 3 is. Okay, just like we did for f of 2. So 3 is less than 5, so f of 3 is going to be f of 3 plus 1 plus 3. Okay. I can simplify that again, so that's just f of 4 plus 3. Okay. And that thing in red, what I wrote in red, is this whole box here. Okay, because I'm going to work backwards in a couple minutes. Let's pick another color. So let me go to blue, because I can't just do this. I need to know what f of 4 is. So if I can figure out what f of 4 is, then I can figure it out. So 4 is less than 5 again, so that's going to be f of 4 plus 1 plus 4. Okay? Simplify, obviously that's just 5. F of 5 plus 4. Okay, and that's what that whole blue box is. Now, can't solve that. Got to figure out what f of 5 is. So let's figure out what f of 5 is. So 5 is not less than 5. So now I jump down. Okay, this is better because I kind of have an end case here. F of 5 is just going to be 5 squared. Okay? And now I can solve that. I don't have to keep working my way down because 5 squared is just 25. Okay? And now I can erase whatever then in this orange in here, this whole thing, f of 5, is just 25. And now I can do 25 plus 4, so that's 29. Now I'll go back to this blue color here. That was 29. And I can go, that was what the blue was, so I can erase this f of 4 and put in 29. And obviously 29 plus 3 is 32. So this whole thing is 32 in red. And I can erase this and put in a 32 there. And 32 plus 2 is 34. So my final answer to this problem is 34. So f of 2 is equal to 34. Now, I don't expect you to erase that if you're doing the math problem. I'm going to go through real quick of what you would see in that case to show you, but that's actually what it's doing. It's working its way down until it gets that base case, and then it can kind of work its way up to answer those questions. Okay, so if you need to look at that again, please do so, because that's actually how it's going. A lot of times if you're just doing the math, this is kind of what you'll write, so I'm going to do this a little bit quicker here. So f of 2 would be equal to f of 3 plus 2. And then we're just going to kind of bring this 2 down. I don't really want to circle it. We're just going to bring that 2 down for the next one. So f of 3 will be f of 4 plus 3, and then bring the 2 down. That's 2 just comes down. That way we don't have to go down and back up. F of 4 would be f of 5 plus 4 plus 3 plus 2. This time you're bringing both of those down. And then f of 5, well, that's just, we kind of do this quicker. F of 5 is just 25 plus 4 plus 3 plus 2. And now you can kind of do it 29, 32, 34. And 34 is your answer for f of 2. So that's what you would kind of do mathematical wise, and what you do when you're going to trace a little bit through these questions. So let's now, I'm going to write this problem in Java, and then we'll kind of look at it and see what we kind of think there. All right, so we jumped into Java, and I wrote the recursive method for the math problem that we just did. Let me talk about a couple things first, and then we'll kind of get down into it. So when you're writing a recursive method, you usually have a base case and then one or more recursive cases. So your base case is kind of to get you out of the infinite loop, to kind of stop you. And in this case, this is my base case. Okay? If x is greater than or equal to 5, return x times x. That gets me out. That doesn't call my function again. Otherwise, I'd be in an infinite loop. My recursive part here is return f of x plus 1 plus x. Okay, and if we remember from before, we should get out 34. And if I run it, I do. All right. We can reverse this. You can kind of put if x is less than 5, return f of x plus 1 plus x, else return x times x. You can definitely reverse these. Typically, we like to start with our base case, because that kind of gives us our way out so we don't get the infinite loop. Okay. You have to be careful on these. These are hard to write. I even struggle sometimes thinking of how to think recursively and write some of these. The more you practice, the more you start seeing it. We're going to do a couple. I'm going to do factorial in a second. We're going to write recursively, and then I'm going to have you try some of your own. But mostly for this week, you're going to be tracing some recursive questions. So let's take a look at Coding Bat. And if I jump all the way to Coding Bat, if you scroll all the way down, there's one called Recursion 1. And we have one called Factorial. Okay. Now, we know, just a little hint on factorial if you kind of forgot. So 5 factorial in math is equal to 5 times 4 times 3 times 2 times 1. 6 factorial will be 6 times 5 times 4 times 3 times 2 times 1, and so on and so forth. All right. So we want to write this. So if we look at this example for, let me actually just copy this and put this down here. If we look at this example for 5 factorial, we see that my base case is really 1 because I stop at 1. I don't want to keep going. I'm not doing times 0 times negative 1, so on and so forth. So I want to stop at 1. So I start off by thinking, okay, if I want to stop at 1, I'm going to say if I send over a 1, so if n ever equals 1, very simply just return 1. I don't want to return 0 because you're multiplying. You don't want to definitely return 0, otherwise you'll get 0 as your answer. So I want to return 1 in that case. So if I send over a 1, let's just run that. Well, I have to put an else here. Let's just see if this works for 1. I'm sure one of the tests will be that. So let me just put in a return 0 for everything else. So if I send over a 1, I return 1, and I get that one right. But if I send over a 2 or anything else, I'm getting 0. So what do I want to do in the recursive case? So in the recursive case, I want to return. So let's pretend 2 comes over. If n is 2, I want to do 2 times 1. Well, factorial of 1 is just 1. So what I can do, a lot of times you only have to look at the first 2 cases and first couple cases and kind of see it. So I'm going to return n times factorial of n minus 1. So if I send over a 2, this would really be 2 times factorial of 1, which then factorial of 1 would get called, which n would be 1, and I would return 1. And it should work. We're going to run through it with 5 in a second, but we should see it. Boom, and you wrote the factorial method recursively, which is really nice if you look at that. That's not a lot of code. So let's just run through it one more time with 5, if n was 5, and see what happens here. So pretend n is 5. All right, you can just kind of see what I type here. So if n is 5, I come down and I return 5 times, I'm just going to put fact instead of the whole method, fact of 4. Okay. Now I can't do anything here because this is still not done. This is not a number. I can't do like, it's not 5 times 4. It's 5 times whatever fact of 4 is. So I have to keep going. So what is fact of 4? Well, fact of 4 is just 4 times fact of 3. And fact of 3 is 3 times fact of 2. And fact of 2 will be 2 times fact of 1. And what is fact of 1? It's not fact of 1 times fact of 0, because when it's 1, that's my base case, I just return 1. So this is actually just 1. And now I can go back because fact of 2 is just 2 times 1, which is 2, so this is just 2. Fact of 3 is 6. Fact of 4 is 4 times 6, which is 24. And 5 times 24 is 120. So I should return 120 back to the program, and it should work for all of them. I don't know if they do. Yep, 5 is 120, and I get it correct. Like I said, that's not easy to do. Right now, I would try to do some tracing problems first, the tracing worksheet, and then come back and look at your coding back questions, okay, which are in Schoology of which ones you need to complete. All right, so take a look and see what you think. Good luck.